Cadence is a contract manufacturer specializing in the design, prototyping, and manufacturing of surgical devices. The Cadence Project Realization Center provides ultrasonic cleaning, finished device assembly, and final packaging and labeling for 27 medical devices. Cadence's sales volume increased by 50% over the 2017 fiscal year, and as it continues to grow, it will be limited by the capacity of the facility given the current staffing and space. The problem statement. Cadence does not understand its current capacity, and therefore it cannot properly plan for new product lines or increase volume for existing products. Due to this lack of understanding, Cadence currently faces problems such as penalties for late orders, inflated labor costs due to necessary overtime, and improper staff scheduling. These problems will significantly compound once the expected growth in sales volume and product diversity increases. Without a way to estimate the current capacity, Cadence is unable to estimate future capacity, which limits expansion. In order to begin addressing these problems, we decided to first begin by documenting the current process steps for production and other peripheral operations. By creating process maps for the facility, we began to gain a better understanding of the flow of the materials and how to collect data. To build a model, we knew that we would have to create time studies for all operations in the facility. Due to the specifications in each process, data was collected differently for each operation, but the end goal remained the same, to determine an hour per unit. Using the time studies we collected at Cadence, as well as creating a means to produce estimates based off of expert opinion, we developed enough training data to begin building our model. Due to the nature of the facility and data, the team developed a tree-based regression model. This type of model takes data points as input and uses them to determine which features of a product are the most important and accurate predictors for an order's total time requirements. The model was ultimately coded in Python with its interface in Excel. The Python script captures Excel data, specifically the bill of materials that we created, training data that we collected, and forecasts to produce data frames. The code combines the appropriate data and cleans unwanted fields automatically. The data is then prepared for the model by shuffling training data to remove bias from the order, extract time per unit, and finally ready for the decision tree model. The code exports the created model as an image file of the decision tree used to predict the forecasted data and creates an Excel file that provides an estimate for how long an order will take at each process step within the facility. Our model is dynamic and can be updated as Cadence collects more data and adds new products. The Excel output utilizes VBA and can be easily used by any employee. We delivered manuals on the model to allow for easy use upon project completion. Additionally, we have created time study manuals and process maps that define each of the peripheral processes. Using our deliverables, Cadence will be able to appropriately handle growth and better address current staffing and delayed shipment issues.